Hey Savage, here is your video. I want to go over some things that I already said you would need to get you ready for FSA. So the two things that I talked about a few. We had multiplicative comparisons, L-I-C-A-T-I-V, multiplicative comparisons, factors and multiples, and prime and composite. And factors and multiples really go with prime and composite, so it's kind of one thing. So let's go ahead and we are going to start with our multiplicative comparison. So here's my word problem. Martha has 12 dogs. She has 7 times as many cats. How many cats does Martha have? So I start off by figuring out, obviously, text coding my problem, and then I write my two things I'm comparing. So I'm comparing dogs and cats. And then I align up my data. So there's 12 dogs, and she has 7 times as many cats. So when I see my data here, I have a number in both of my comparisons, which means factor times factor equals multiple. They're both factors. 12 times 7. And I know my multiplication table, so 12 times 7 is 84. So she has 84 cats. She's a cat lady, obviously. All right, let's look at our next multiplicative comparison. Ronnie walked 25 miles. He walked 5 times as many miles as Dave. How far did Dave walk? So first thing, text code, which is done. And then I have to determine what I'm comparing. So I'm comparing Ronnie and Dave. And then I write my numbers. So Ronnie walked 25 miles. He walked 5 times as many as Dave. How far did Dave walk? So when I look at my data, they are both on the same line. They're both at the same piece of data, which means I have to have a number on both sides of the equal sign. So 5 times as many obviously goes with the times, and 25 goes here. And to solve for this, I think to myself, what times 5 equals 25? And I am able to figure out that Dave walks 5 miles. All right, so that's our multiplicative comparisons. Now, let me go into factors and multiples. So factors are what you multiply together. So factors are what is multiplied together. So for example, 5 times 7. Those are my factors, okay? 1 times 35. Those are my factors of 35. Multiples are the answers. Multiples are the answers to answers. So 2 times 1 equals 2. You see how I don't have answers here? That's my multiple. 2 times 2 equals 4. That's my multiple. So if a particular question says, what are the multiples of 6? Well, multiples of 6 are your 6 times tables. 6 times 1, 6 times 2, 6 times 3, 6 times 4, and so on. Now, one of the problems may ask, what are all the factors of, let's do 9. So list all the factors of 9. List all factors of 9. So what I do is I think what two numbers multiplied together equal 9. So obviously we start with the easy ones, 1 times 9. Those are the easy ones. And now I think to myself, is there anything times 2? Well, it's not an even number, so it can't be a 2. 3. Well, 3 times 3 equals 9. And I can stop there, and I know I can because it's a repeating digit. Once you're repeating, there's not going to be any other factors. Or once you're a factor next to a factor, like 3 times 4, there's no more. Once you get there, that's all you have. So that's how I determine my factors. So let's say 12. Let's do factors of 12. Factors of 12 means all the numbers I can multiply together that equals 12. That's the highest number it can be. So I have 1 times 12. I have 2 times 6. and I have 3 times 4. And I know I've stopped because I have two numbers that are backed up to each other, 3 and 4. So these are all my factors. And when I need to list my factors, I go down, around, and up, and then they'll be in order. 1, 2, 3, 4, 6, 12. All right, so prime and composite, like I said, go right along with factors and multiples. Prime numbers have only 2 factors. So let me turn this paper, save that paper. Prime, only 2 factors, only 2 factors. Composite are 3 or more, 3 or more. So the number 9 would be composite because it's 1 times 9 and 3 times 3. It has 3 factors because you only count the same digit once. So 1, 3, and 9 would be the factors of the digit 9. So if I have the digit 2, my factors of 2 are 1 times 2. There's nothing else that I can do to make 2, so it is a prime number. Now, some tips to help you. If it is even, all even numbers, and when I say even, that means even in the ones place. All even numbers in ones place are composite. You don't even need to figure them out. If it's just asking you if it's prime or composite, if it's even, it's composite. Or composite. If it has a 5 or a 0, a 5 in the ones, composite. It is composite. So these are some tips to help you out. The number 1 and 0 and 1, 0 and 1 are neither prime nor composite. They're special numbers. Special numbers. The number 2 is the only even number that's prime. Only even number that is prime. So these 4 tips really help you out. So if I have to do, let's say I've got 7, 12, 33, 45, and 50. And I have to determine whether they're prime or composite. So I'm going to go through and I'm going to do my rules first. So I'm going to look for anything that's even in the ones place and I'm going to mark it. So 12, a 2 is even. That's composite. 0, that's an even number in the ones place. That's composite. So I have a 7, a 3, and a 5. Those are all odd in the ones. So this rule I've done. Now I go to the next rule. 5 in the ones place. That makes this composite. That leaves me with these 2 that I have to figure out. Because odds you're going to have to work. Sometimes the odds work, sometimes they don't. The one thing I can tell you, check your threes tables. That is usually, if it is an odd number that is composite, it's usually the threes tables that help you. So 7. 1 times 7. I know that's it. And I can't think of anything else. So 7 is prime. Now 33. So I obviously know 1 times 33. But then I think to myself, is there anything times 3 that equals 33? Well, that's 3 times 11. So that makes 33 composite. All right. Hope this video helps. Thanks for watching.